Hi, and welcome to this video on file handling in Python. Hi, I'm Raghavendra, an expert in AI, ML, and data engineering. Text files are stored on disk. It can be accessed in our Python programs. In this video, we're going to learn different operations in handling files, that is to open a file, read the contents and display them, write to a file, and append to an existing file. So here is the code to open the file. So open is the name of the function, and I pass the name of the file to be opened. So it's assumed that this file exists in my hard disk, and since I'm not specifying any path, this file is assumed to be in the current working directory, same as my Jupyter notebook. So sample.txt is going to be opened, and fhand is going to be a file handler or a reference to reference this file at a later point in time. So I have opened the file, and this is the file object, a reference to the file. And the first function which we are going to apply is the read line function on the file handler, and I'm going to save the lines read in the object text1, the string object text1, and I'm going to print it out. And once I'm done reading the content, so I'm going to close the file, say fhand.close, so that the file handler, the object is going to be deallocated from memory. Okay. So here read line is only going to read one line, that is the first line, and the string is going to be saved in string text1. I'm going to print that. After that, the file is going to be closed. Next, again, I am going to open the file. So when I don't specify the mode of opening, in the previous case as in the current case, so the file is going to be opened only for reading by default. So I open the file, and here is the reference to the file. And instead of saying read line, I'm just going to say read. Let's see what happens. I'm going to close the file, and I'm going to print whatever I have read. So whatever I have read is saved in text, and I'm going to print it out as well. Yep, the entire file content is going to be read into the string object text, and I'm printing it out. Next, again I'm opening the file, and instead of read, I'm saying read lines. I'm saving whatever I've read into a string object text, closing the file, and I'm printing the text. Let's see what happens. Here, every line is going to be read into a list, right? So I have the first line here as the first element of my list, the second line into the second element of the list, third line into the third element of the list, and so on, right? So this will be useful at times where I would want every line as separate elements of the list, and later I can iterate the list if I want to process the lines which were being read. So next, what I'm going to do is I'm going to open the file, and I'm actually doing it in a very different way, not like before. And I'm going to use a for loop to implicitly read one line at a time, and then I'm going to print it out. So here I'm not even closing the file. So let's see, there are some implicit operations which are going to be performed over here. So I'm going to use a with block. So I'm going to begin a block with opening the file, and I'm aliasing the file handler as fhand. That's the reference to the file. So then I'm running a for loop for line in file hand. So you don't see a read or a read line function over here. The file is going to be implicitly read one line at a time, and it's going to be stored in this object, and you can perform any operation on that particular line. So I'm printing it over here. So I don't have a close function over here. So the moment I am done with this block, so the file will be automatically closed. So I don't need to do that explicitly. So I'm beginning a block with opening the file and calling the reference as fhand. I'm going to do all the operations. The moment I come out of that block, it will be automatically closed. I don't need to worry about closing the file as well. So this is a clean practice while dealing with files. Yep. So I have every line read one at a time in this for loop, and I'm printing it out. Next is I'm opening the file for writing, right? So I have a file called programming.txt. If it already exists, the contents are going to be overwritten. If it does not already exist, so it's going to create a file and it will start writing the contents. Yep. So I'm setting the name of the file as programming.txt. I'm saving this in a string object. I'm going to begin a block with opening a file as f. This is the name of the file handler or a reference to the file. I say f.write, and by the way, please note I'm opening the file in write mode. I'll have to be very explicit if I would want to open the file in write mode. So I say f.write, I say mention this line, I love programming. Right? So let's see what happens when I execute this. And I begin the block by opening the file, and I will be implicitly closing the block by closing the file. So I'll be exiting the block by closing the file. So I don't need to have that statement over there. So let's now go to the folder and check the contents of this particular file. So here in this directory of my Jupyter notebook, you have this file being created, programming.txt, and you have this line, I love programming, which has just come up in that particular text file. So let me close this. Now I'm going to write into the same file with some more lines. So it just had I love programming. So to the same file, I'm going to open the file once again. And then I'm going to write, I love too much programming. I love creating new games. Hi, I'm doing good. I hope. I'm writing multiple lines. So write is going to write one line. So I as well put a new line so that the next line I write appears in the next line. So /n is required there. So this line comes in the next line, /n, this line comes in the next line, and next line. So the last statement is used to write multiple lines in a single statement. So let me execute this. So totally I'm writing 1, 2, 3, 4, and 5 lines. So I'm writing 5 lines into the file programming.txt, which is in the same working directory as my Jupyter notebook. Let me execute it. Let me go back to the folder and check the file. Let me open that file. Yep. So I have 1, 2, 3, 4, and 5 lines. This file earlier had 1 line. Now I closed it and reopened it in write mode and wrote 5 lines. The previous line which I had written is overwritten, gone. So please be very careful. If you are opening a file in write mode, ensure that the file does not have any content. So previous contents are actually lost there. But if you would want to continue writing towards the end of the file, then you will have to open the file not in write mode, you will have to open it in append mode. That's what we're going to see next. Let me close this file. Now, if the file does not exist or if the file is empty, it creates a file and it writes into that particular file. But if the file already exists, like as in this case, programming.txt already exists, so append is going to add the contents or write the contents towards the end of the file. It does not overwrite the existing content. Let me see. I'm writing 2 lines over here. This writes 1 line and this writes another line. Let me hit enter and execute this. Let me check the contents now. Yep. So you had 5 lines before, to which 2 more lines are added towards the end of the file. Yep. So totally 5 plus 2, 7 lines are there in this file programming.txt. Great. So far it was a very happy case scenario. We had the file in the same working directory as our Jupyter notebook. So we were just referencing the file by its name. But if the file is present in a different working directory, so we'll have to specify the path. So I have a file in a folder test within my desktop, right? And then I'll have to specify the entire path. So here is that particular file, which is, I'll just copy this path, C:users Raghavendra in desktop test, and I'll have to reference to this particular file programming.txt. Right? In fact, it is programming1.txt, which I'll have to reference. So let me execute this piece of code. You are going to get an error. Backslash in path are not recognized. Backslash in Python has a different meaning. So path separators in your Python code cannot have a single backslash like this. So path delimiters, there has to be a caution to be maintained while specifying these path delimiters. So there are different ways of specifying the path. Either you can use a double backslash to denote the path. So let me set the file name to this path, and I'm referencing this file present in the test directory within my desktop directory, and I'm going to open that and I'm going to read line by line. Yep, it's all successful. Alternatively, I can even specify a Unix-like path, right? Instead of a backslash, I use a forward slash. I'm going to change all my backslash to a forward slash, and I am going to read the contents. Yep, this as well works. Also, I can use this character R before my entire string, and I can give the same Windows path as is. So I'm instructing my interpreter that the slash which comes over here is to be treated with a special preference. So I put a R over there. It means that please treat the path literally, don't take it as a different meaning there, because slash in the context of Python will actually mean that you're trying to escape some characters. So here it actually means to be treated as a path delimiter. Now as well, the contents are going to be read. So you'll have to be a little cautious while you are specifying the path. With the path delimiter, you can't just have a single backslash. If you would want to use it, you'll have to use a double backslash or a Unix-like forward slash, or a single backslash should be, the string has to be prefixed with the R, indicating that to treat that path delimiter literally and not to take a different meaning there. Yeah. So in this video, we learned about different techniques to perform operations on files. Thank you for watching this video.